welcome back to our second panel of day 2 of gridXdays. I just want to remind everyone who's watching that we do have a live question round going. So if you have any questions for our panelists that come up, please feel free to pop them in and we can ask them. This panel is retrofitting, making dumb hardware smart. Joining us, we have Annike Abromeit. Annike has worked with EEBUS initiative for over 3 years. She currently serves as the Innovation and Communication Manager there, where she helps with the acquisition and initial coordination of new research and development projects, among other tasks. She is an ambitious, creative, and open-minded young professional who is motivated to boost green energy and sustainable resource management in economy, politics, and society. And we are also happy to welcome her back after previously having her as a guest speaker on our podcast, What's Up with Energy. Joining her, we also have Tobias Mitter, our own Managing Director and CTO here at gridX. He leads product development, engineering, and production with a background in digital platforms and IoT solutions from roles at BCG, IBM, and various startups. He brings extensive experience in digital business models in the energy and automotive sectors. And we also have Ali Bouattour. I hope I pronounced your last name correctly.
Perfectly.
Ali is a seasoned leader in renewable energy, bringing a unique blend of technical and business expertise to drive growth and innovation. With a global perspective and deep experience across solar, PV, energy storage, and electronics, he excels in connecting technology, teams, and customers for impactful solutions. And then finally, we also have Andreas Schmalenberg. Andreas is a senior product manager at KOSTAL. He has been the product manager for several global teams and has extensive experience with PV inverters. He received his engineering degree from the University of Applied Sciences and Art at Dortmund. So welcome to all 4 of you. Thanks so much for joining me this morning. And we will actually start off with our first question to Annike. In your opinion, what are the primary challenges in retrofitting legacy hardware to be smart and connected?
Okay, thank you, Tajir, and hi, everybody. So from EEBUS side, we definitely see a main risk or challenge in the security, equipment, and infrastructure of those existing devices that are installed and running in buildings. So those security functionalities are not state-of-the-art as they are with new devices. And this has to be included, of course, in the integration of those devices into an energy management system. And then also those devices all behave differently. So depending on the vendor, they all have different algorithms, logics, they just behave differently, which has to be considered when integrating and connecting. And then, of course, there are pretty high initial cost in the setup and installment of the connectivity of those devices into the home energy management system, and also high maintenance costs. So when you want to keep those devices connected and functional in the sense of an efficient energy management system, there's always an alignment necessary once the one side is changing anything. For example, with Modbus, if you have a change in the register types, then of course the energy management system, as let's say the partner or the pendant, also have to come up with a change and an alignment. So that's the continuous work or effort that has to be done on this side. So that's what we see from EBA's side as a main challenge.
Okay, and the other panelists, would you guys have anything to add to this? No.
Sorry. Well, I mean, if I'm I can come from my side that, yes, I mean, certainly there are challenges and there are additional costs and risk and so on. But what we see from our side as Goodwe is, of course, it's important to look at these retrofit projects in a case by case, because at the end, every user might have his different target. He will have different equipment, different legacy system. and also you can find the right setup for the user.
Okay, and Ali, actually, my next question was for you. How can we determine which assets are best suited for retrofitting versus those that just need to be replaced?
Well, I mean, we start, first of all, why is the user looking to retrofit a system? So usually, I mean, they want to add an asset, they want to add a heat pump or an EV charger, or they want to maximize the use of their own produced PV. Maybe they also want to participate in the energy market with a dynamic tariff or some of the new services that are out there in the energy market. And the question, does my existing system, is it suitable for this? And then, well, the key is like similar to what Annike mentioned. Of course, communication is the key here, because you want the new equipment that you're adding to be communicating with your existing ones, with your existing system. And I mean, if you have a very old system, let's say 10 years or more, it's very likely to be dumb and not communicative. If your system is a few years old, you might have a good chance to find your equipment still supported in compatibilities and communication protocols with either within the same manufacturer. So you look to your existing manufacturer and you add equipment from, for instance, you add an EV charger from your inverter or energy storage provider. Or, of course, you look for a solution with an external EMS system, with an external energy management system. And here's the key, is the communication. So ask your manufacturer or your installer, or go to an EMS provider, look for the compatibility lists, make sure that the manufacturers checked these compatibilities for you, so that when you add an equipment to your existing system, that you have a peace of mind that it's working the way you expect it.
And then, Andreas, what are the cybersecurity risks associated with retrofitting older systems?
Yeah, usually the older systems, like PV inverters, for example, they are using the HTTP unsecured communication protocols. So this could be a problem that some kind of security attack is done against these devices. There is a risk that, or the problem with the older systems, that you cannot get always the latest software update. So because maybe the old systems, they cannot be updated, there is not possible to get software update, which closes some security problems. So the improvements for security are not always possible to be updated with these old systems. So it's easy to perform the cyber attack, especially if any customer or any system is using a port forwarding solution. So this is really a high risk about the security. So an inverter could be switched off, for example. There are some intruders can take over control of your inverter and can switch it off. So this is one of the risk, the main important risk which I see. And yeah, you have to check, is this this device, is it still okay? Is it still protected somehow? Is it possible to protect the device against cyber attacks? So maybe just switch off external access out of the internet to this device. Maybe use some kind of remote service, some kind of VPN connection, some kind of secure connection of HEMS, for example.
And then, Tobias, what role, in your opinion, does IoT technology play in transforming these dumb assets into smart ones?
Yeah, I think that is something that we see across the industry. Yeah, so companies like the OEMs like KOSTAL, Goodwe, yeah, also investing into making their devices smarter, but in general also when it comes to the interconnectivity of things, yeah, for the user, that IoT plays a crucial role, yeah, and maybe also for being clear about also what I mean by saying IoT, yeah, it stands for Internet of Things, yeah, it usually means like they have decentral decentral connectivity of then also decentral assets. That's what we usually then also find in people's homes if they have PV, if they have battery, if they have a charger, EV, and so on, and a heat pump. So how to connect this and how to make those dumb assets then also smart ones, and that is really important because luckily we see a great uptake on renewables in all markets. And in Germany there was this statement, I think from NPAL and 1,5, yeah, who did a press release on, okay, if we do not get into more control, yeah, we might have a blackout at next Easter weekend, yeah, because there will be so much PV that is uncontrolled and the sun comes out, yeah, and if there's no control, the grids will really face a struggle, yeah. So it's also making dumb assets smart is also not only for the benefit of the user, which has to come first. It also has to pay off, yeah, to control the assets that you own. But it's also important for our overall grid stability, and that we see in the new renewables joining the grid. And IoT plays there a key role because we already heard that there, if you have like a Goodwe or a KOSTAL setup, it might be easy then also to add another asset to it later on because you get an EV at a later point in time, and it gets controlled already because the devices know how to talk to each other. But in many cases, we also see that, for example, if you purchase a heat pump, yeah, and upgrade from gas to heat pump heating, that might be a different OEM. Yeah? And there we come into the question of how does it communicate? That was also mentioned by Annike and Ali already. That is like a kind of key challenge where IoT devices can help, that sit in the middle and kind of translate those different languages that the devices speak and achieve a level of control that is in a perfect world secure, that is also kind of robust when it comes to internet outages, but first and foremost enables then also the customer benefits by, for example, participating on the energy market using dynamic tariffs, or making sure that you use your solar energy in the best way possible for your own energy consumption, yeah, to save money basically in the end. Yeah? Mm. And this also helps to make the grid stable.
Yeah. Annike, how can we ensure data consistency between retrofitted and smart devices?
Well, for us as a communication standard, we do see that an use case approach or a use case based connectivity is necessary. So if there is an energy management system that has integrated a standard like EEBUS and that wants to integrate the existing device in terms of certain, let's say, applications, then the approach has to be top down. So whatever the energy management system with its use cases wants to fulfill has to be enabled by the existing device, meaning that it's not thought the other way around. Whatever the end device, let's say the existing device brings along, but the perspective should be on the energy management system, and then see what kind of mapping is required to make the functionality or the use case happen with by integrating the end device. So the, let's say, device control is then dependent on the energy management system and what kind of use cases the energy management system can offer and wants to fulfill. In this case, or in this way, we can ensure that there's let's say, a maximum of efficiency up and running in the system. Because in the other scenario, as I mentioned earlier, there's a lot of work and effort to be done and to be handled in the, let's say, lifetime of an end device, because then the energy management system always has to integrate and align those functionalities and control, let's say, mechanisms of the end device. And if you have several end devices, several existing devices, and one energy management system, that's a, let's say, less efficient approach.
I think that actually ties in really well with my next question, which was for Andreas. And do you believe that retrofitting impacts the lifespan and efficiency of existing assets?
Yes, I think so. From an inverter point of view, from the inverter side, it is designed to keep or to live for 15 to 20 years. So older inverters, which are still working fine after several years. Please don't waste them. Just continue to use them. Because this is a benefit if you use something of a grid box, for example, some kind of energy management, which makes this older hardware smart. It's a question of costs as well. So not everybody wants to buy a new inverter. From KOSTAL point of view, okay, it would be nice if you buy a new inverter every year or every 5 years at the end. But I see there is really benefit to have to increase the efficiency as well. So just keep your inverters, your hardware running, and then increase the efficiency of the system by using some external energy management. Yes, using, for example, energy management to achieve a high self-consumption rate, to achieve a high rate of own consumption. And maybe use the dynamic tariffs, which will come out in Germany next year in mass. So from my point of view, it's really no issue thinking about retrofitting. It's working.
And then just to clarify, you were saying that an inverter will last 15 to 20 years regardless, or last 15 to 20 years when you include the retrofitting?
So this is independent from the retrofitting. So just calculate. So everybody is calculating 15 to 20 years, hopefully more. But this is more or less a golden rule in the power electronics of inverters. And we cannot do anything against this calculation. Of course, as less of yearly PV energy yield will go through the inverter, it will increase the lifetime. This is a really important topic to be considered as well.
Okay, and then actually, Tobias, I'll kind of put that question to you as well from the energy management side of it. Do you see retrofitting as impacting the lifespan or the efficiency of assets?
Yeah, I think so, because many people have started, especially in the ones that were early to the game, with having a solar system, and then at some point they might want to add a battery, or they might have then also taken the decision to add a heat pump or an EV. So of course, there's this world of a big setup coming into a new house, but we also have the existing setups that also need to grow, that need to evolve. So also what Andreas that resonate there a lot for me. And I think there, as an industry, we also have an opportunity to really make the energy transition even more paying off for more people by making retrofitting easier. And things like thinking about the communication, how can we solve also the communication challenges that still exist between different kinds of devices, as also Annike pointed out, is key to that. But I would even say it starts one step before, because right now it's also sometimes hard if you're not staying within one OEM ecosystem to find out whether you can really kind of retrofit, for example, a home energy management system and add a heat pump, and will it work? So here being very clear towards installers as well as to end customers, and to give them information of what actually connects and what actually works, is really important. Standards like EEBUS and others can be like a good signal, to understand, okay, will it work together? But I think there's still some way to go in terms of making it even easier for installers and also for end customers. That's why we aim for, and also happy to talk about this with companies like KOSTAL and Goodwe. How can we make it even easier by aiming for something like plug and play, and collaborating closely on making it a bigger business, but also a bigger customer benefit in the end, because retrofitting really allows to make a lot of dumb systems that are still out there in the field smart. If we solve this communication challenge and also the security challenge that comes with that, that's maybe a separate topic. We can touch on later.
Great. And actually, we've had quite a few viewers join a bit later. So just want to remind everyone again that we do have a live question round where you can submit your questions and they will be asked of the panelists. And now, Ali, what do you believe are the main cost considerations when retrofitting legacy systems?
Yeah. Well, cost is an important factor. I mean, as just Tobias said right now, I mean, we want this we want to make this scalable, to use the huge potential of millions of existing legacy systems and retrofit them. And there are two aspects of the costs. There is an initial investment and there are operating costs. And for the initial investments, of course, we want to make the existing equipment smart to avoid any replacement, because that is a key factor. So assuming the manufacturer himself can upgrade the equipment, or using an external EMS partner like gridX, for instance. So of course you'll have that cost of adding that equipment, which, I mean, compared to changing the existing installations, will be still much more competitive. And of course, there are the installation costs. So this is in terms of initial investment. The key is to make this, of course, this hurdle of initial investment as small as possible for the user. Yeah? So therefore, it's important also to use here components that are compatible, that are plug and play, so that also the installation effort is limited. Then the other aspect are the operation costs, and this is coming back to the point of, I think Annike mentioned also, or maybe so it was mentioned earlier. We look here at systems that are supposed to run for 10, 15, 20 more years. And manufacturers will change their communication protocols. There will be updates, there will be changes, there will be maybe further assets coming up or being added in the future to the systems. So here, a key to make this future costs or the operating costs under control is to look for system combinations. If you are combining an asset with a third-party EMS, to look for companies that have a strategic relationship, that work together, that have aligned processes between each other, to make sure that even future updates and changes do not come with added costs on the user side.
Okay. And then Andreas, kind of going off of that, how do you see us measuring the ROI of retrofitting projects compared to complete replacements?
Yeah, so it's difficult to say. So it belongs always about the existing PV plant, the existing system. So, for example, as we discussed already, if it's really old, if you can see maybe in the monitoring some problems with the inverter. If you want maybe to add a battery to the system and so on, you must think about to update the complete system. So to renew the inverter system, maybe take a hybrid inverter. And in the most cases, you can keep your PV panels on your roof. This makes always sense, because it's high cost to exchange it. And maybe it makes sense to just to exchange the inverter against a hybrid system with a battery. In addition, you can check how is it possible to increase the self-consumption rate? How is it possible to increase the self-consumption rate of the complete system? Makes it sense maybe to add a new energy management system like the gridbox, which helps with special algorithms to combine all the existing devices like heat pumps, like wall boxes, so e-vehicle charging, like batteries, to have a better return on invest. Yeah, this could really improve this complete ROE rate. For as a tool, for example, we are using some special solar planning tool, which will come out in a web-based version in a few weeks. So this is always good to start up with. If anybody's interested to exchange something in the system, to retrofit it, take this kind of planning tool and just simulate about your home consumption, which you have each year, about the size of the PV, size of the battery, and this tool combines all this information and will calculate for you the ROE.
Okay. And then actually, Annike, I'm just curious with EEBUS, how would you guys maybe measure the ROI of retrofitting projects compared to the complete replacements?
Well, for us, as I mentioned earlier, it's important to have these use case based approach, and if that's not to be fulfilled, or if that can't be enabled with the end device or the existing device, then it might be also on the sake of the energy system and the end customer for its own energy efficiency on site, might be suitable to replace a device. But if, and then it depends on what the end customer and what the energy management system wants to have the end device integrated for. If that is somehow manageable, so if there is a possibility of an adapter from an IP-based communication protocol to Modbus, or if maybe for those use cases that the existing device should be integrated, like power limitation or dynamic tariffs or self-consumption optimization, there is the chance to integrate an adapter to this specific device to make those requirements or functionalities inside the device behaving accordingly the signals that the energy management system is sending. Then, of course, the device can stay inside the building and does not have to be replaced. I mean, from EEBUS, we have developed a standard that was made for the, let's say, new devices, or that is to be integrated by manufacturers who are now producing devices that are to be installed or that now have started to be installed. We would recommend to integrate whatever is there if it's possible, if the functionality, the interface of the device can be connected to an adapter, and this adapter is mapping the signals from the energy management system in alignment with standardized use cases. But of course, if the existing device is, let's say, really dumb and not able to be integrated, not even for the, let's say, low-hanging fruit use cases, then of course you might think of a replacement.
Maybe to add to that, because especially with EEBUS and for Germany, there is a clear retrofit case that might be interesting for homes and homeowners that have systems in place for some years now, which is the so-called 14A regulation. That was introduced beginning of this year and will come into full effect from next year. And there, basically, the idea is you get rewards as an end customer in terms of, by having reduced grid fees that can go up to 550 euro of a benefit per year of saving if you also have a heat pump EV and so on. If you let the grid operators control and dim your devices in case there is a grid emergency. Yeah? So it will happen very, very rarely, probably, hopefully. Yeah? And this is something where the signal then gets transmitted to the home, and there EEBUS is part of the standard that is used to do it. And retrofitting can be here very interesting because as Annike already explained, not all devices can speak EEBUS today. Yeah, but the signals comes in via EEBUS, and using now an IoT device like a home energy management system, you can translate it basically also back to devices that are older that are not supporting EEBUS, and you can still benefit from that reduced grid fees and this up to 550 euros per year as an end customer, which is, I think, a great retrofitting case and something that also makes dumb devices smart, helps the end customer, helps also grid stability, and is a great return on investment case in that small scale, as an example.
And then we did actually have a question from the audience, going back to the life expectancy topic. And so they say, regarding the life expectancy of inverters, does Goodwe, KOSTAL, gridX publicly share studies or data on the physical life expectancy of inverters?
Yeah,
well, I can.
Sorry, go ahead.
No, go ahead, Andreas. It's fine.
So we are not sharing special deep dive studies. We are doing our simulation internally, R&D work, and then for us it's a must that they keep alive the inverters up to 50 to 20 years.
Yeah, well, and if I add from our side, from Goodwe side, of course, I mean, there are design, there are testing, there is life expectancy, there is also past experience on. We talk about millions of existing installations that we know also that what to expect in terms of lifetime from the inverters, and warranties is also a good point of orientation for the users. I mean, we know we give 10 years is the standard right now in the market for the inverters. And this is a sign that we are confident in our technology, in our products.
Yeah, maybe to add to that also, because would fully second what Andreas and Ali said. But forward-looking, I would also see a responsibility with EMS providers like us, in collaborating closely then with manufacturers like Goodwe and KOSTAL, because we will control assets also from the outside, and there might be more control in the future. Which means there is more charging, discharging, so the cycle time will become a topic. And there I think we need to collaborate very closely to fulfill the promise that the manufacturer basically gives to the end customer in terms of life expectancy, while having good control at the same time and getting the benefits of that. And I think there we need to really collaborate closely to make this work, because we do not want to be in a situation that we have perfect control, but we have a problem with the life expectancy of the hardware. That is something nobody wants. So there also close collaboration is important. And I think they're also communicating between the devices, also balancing out the benefits of control, but also the benefits or the kind of control that benefits the hardware is super important. And that's why I'm also very happy that we have these close collaborations and discussions and take that forward in the future.
Yeah, I mean, to take on this here, I mean, extremely important what you mentioned here, but also coming back to one of the earlier questions, which was related to the impact of the energy management system on the life expectancy of the device. I mean, of course, if you put your existing system, which was purely producing PV or just doing one cycle per day on a classical PV self-consumption with storage mode, and then all of a sudden it gets an extreme number of charging cycles per day, that might have an impact. But still, when we look at the use cases and the use cases that are now driving, I mean, dynamic tariffs, for example, we're not looking into adding 20, 30 cycles per day. So these are also still things that are within the scope and the capabilities of the hardware that we already put in the market. So here also to take out a little bit the concern from the users, which is of course understandable. Here it's important also to mention that whatever use case we're looking right now, it's not something that is completely out of the range that we already know.
And then Tobias, are there tricks to accelerating retrofitting adoption? And if so, which approaches are available to make it happen?
Yeah, I think tricks are. I think good communication is key. To really address concerns and questions for end customers, but also for installers, who are a really important group. To make retrofit happen. And I think there again, having communication from the manufacturer, from the energy management, from the standard provider side, like EEBUS is key. To really work together to make it as easy and as simple as possible. For example, to understand what's the compatibility between different devices. How can I really make retrofitting in my specific situation with the setup I have at my home work? And then the second the second thought on tricks would be, it is perfect if we have like a seamless plug and play solution in the end, but there are also steps towards that. Yeah, so we've seen also successful retrofitting by providing good information to installers how to do it. Yeah. Sometimes also having very clear guidance, sometimes even by phone. We had a case with one energy company that retrofitted a couple of thousand customers that had inverters already in the field. They got sent the new energy management system box, yeah, that they were supposed to install, and then you did a phone call, and basically the agent took you through the steps what you have to do at home. Yeah? So there are also creative ways on how to do that, while we are also heavily working in the industry on making it as easy and as plug and play as possible. Yeah? But we don't have to wait. Yeah? There are steps in between. And I think if it's if you find the right communication touch points along the journey for the decision, then also for the installation, also for the maintenance, I think there's big opportunity. I think Ali mentioned it. Yeah, there are millions of devices to be addressed in Europe. Yeah. Where people could benefit from an additional battery, from additional home energy management, etc. So let's tap into that and be creative about it, yeah, because there are different ways to do it, and it's possible today already, yeah, to have successful retrofitting.
And Tobias, if as you say, I mean, if we make systems that are plug and play, that an end user is capable of adding an EMS and it's done, I mean, that is the ideal scenario. And this is, I mean, the trick is to make the ROI of the use case as attractive as possible to the end user at the end. Yeah. And that comes, of course, with the standardized compatibilities and the standards and EEBUS and etc. So that's the technical side. The other aspect is the operational side. I mean, if it's very easy plug and play and based on close collaborations between the players, then it makes it even more competitive and achieves a higher ROI for the user.
Nice. And we're actually coming to the end of the panel. So I just kind of want to make sure we get in this last question. It's to Ali, but I think all of you could talk about it. How can retrofitted systems contribute to a more resilient, adaptable, and sustainable energy grid?
Well, that is a very nice question. I mean, it's again, potential is huge. There are millions of existing systems. And these legacy systems have the potential to participate in on one hand, if we retrofit them to either increase their self-consumption, be managed in a smart way, that the added EV charger, the added heat pump, increase the local consumption, self-consumption of the existing PV. That is beneficial, of course, for the energy transition in general, and also beneficial for the grid, because the electricity which is produced locally is consumed locally. So that is an ideal case. That is one aspect. And the other aspect, all of the systems can be, made capable of participating in the energy market with dynamic tariffs, with other grid services. I mean, the previous panel was talking about several countries. I mean, we have imbalance markets, we have frequent FCR in Sweden, et cetera, et cetera. So there's potential of all of this. All of this existing installations to be part of the energy market, to contribute to stabilizing the grid and also reducing the efforts needed to expand the grid infrastructure.
And Tobias, Annike, do you guys have anything to add?
Andreas, I would also invite you to.
Well, yeah, Ali said it all, I would say. I can only repeat that using these, let's say, until now unlocked or unused potentials just creates benefits for everyone, for the end user to make most out of their own flexibility and remuneration of flexibilities, for the energy provider to have a new asset to be incentivized and to be managed, for the grid operator who has a new, let's say, player in the game of making the grids more stable. yeah, so in the end, I only see a benefit to unlock these potentials and to integrate them into the energy market, into services, and actually to push forward and enable the energy transition as a whole.
Yeah, and now we are, let me say, I'm really happy with solutions like the Gridbox. So Tobias, is just a little bit advertisement now for you, because
I'll take it.
it helps. Yeah, it really helps to get this retrofitting done and to make the grid services smart. Yeah, this was just from my point of view, it just was a problem that in the past we had not the real finished fixed standardization about how to communicate, how to integrate all the use cases with inverter PV, batteries, heat pumps, electric charging. This was missing, and the energy management system, they help to combine all existing systems, devices together. And so I'm looking forward to have then now this final standard like EEBUS, which really makes the world for all of us more easy.
Nice.
Yeah, maybe building on that and also connecting to a question that I see from someone on 14A, because it was about grid stability. I think there's also the great opportunity to combine the interests of grid operators, to have some kind of control over what happens out in the field, with how to make it best digestible and also best experience for the end customer. For example, what we try to do whenever 14A happens is that we take the local production, self-consumption, etc., into account and try to minimize the dimming effect that the grid operator wants to send through, because we know what happens in the local home. So there might not even be that much consumption from the grid, which the grid operator doesn't know. They just say, okay, for this whole city area or for that whole street, I need a dimming now. And we can take into account, okay, how can we compensate also within the home so that the user comfort stays as optimal as possible. So and that is something that where I think all the technologies that the manufacturers provide with the steerability from the assets, what we provide as an energy management provider, what EEBUS provides then as the interface, then in this case to the 14A signals, beautifully come together. And now connecting it to the question that I've also seen in the chat, if there are older devices like a heat pump that cannot be throttled, is it also okay to fully switch off the device? That is still an option that most of the grid operators foresee, at least for the next couple of years, to have like a hard shutdown of a device. However, even for older heat pumps, usually SG Ready might be available. So I would recommend to look into that, because that is already some kind of interface that we can also use then for 14A. Most of the grid operators say the digital interface is the future, but of course there's a transition time where you can also like have to hard cutoff systems.
Well, thank you so much. That actually brings us to the end of this panel today. So thank you, Ali, Annike, Andreas, and Tobias for joining me. And for the rest of our viewers, we'll see you back here at 1 p.m. for our next panel, How the Energy Transition is Reshaping Society.